we're looking at some test questions that you might see on standardized tests, like we used to take when we would do the Explore test, but these kinds of things would come up on the map test. So today in class we talked about how to read a ruler, and they're broken up into sixteenths. But what I was focusing on today was three-part ratios, like this one. So you've got the ratio of three side lengths of a triangle are 3 to 4 to 5. So that ratio gives you the comparison of the sides, of their sizes to each other. So if I picture it here, I've got this triangle, and it's got a short side, a medium side, and a long side. And we know the perimeter is 96 centimeters. So what I went over in class today was how to use what's called a tape diagram that they use in Singapore math in Singapore. How to use a tape diagram to solve this. So I'm going to draw this tape here, and I'm going to write what I know about this problem. Now the tape represents the entire thing, the entire value, whatever it is. In this case, we have a 96 centimeter perimeter, so everything adds up to 96 centimeters. So I just kind of put that at the bottom or the top, either way. But that's what I'm going to label as my total value here, 96 centimeters. Now I know that this comparison, the size comparison, is 3 to 4 to 5, a part to part ratio. But the key here to solve this problem is to look at the number of pieces in this ratio, 3 to 4 to 5. If I add all those up, I get 3 plus 4 plus 5. That means this ratio is taking the 96 centimeters and breaking it into 12 equal pieces. So with my tape, I can divide that up into 12 equal pieces. So there's 2 equal pieces. If I break this up, try to go 3, that would be 1, 2, 3. Another 3, so that's 6. And if I break those in half, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got 12 equal pieces. We're just going to assume those are 12 equal pieces. So I've got 12 pieces. And again, I got that from just adding up the number of pieces in that three-part ratio. 3 pieces to 4 pieces to 5 pieces. So now I can take this 96 centimeters and break it into 12 equal pieces. So I'll just take 96, divide it into 12 equal pieces. That means every piece is worth 8 centimeters. So this piece, every piece is worth 8 centimeters. And that's important because I can use that with my three-piece to 4-piece to 5-piece ratio to know how long each side is. Because I've got all the information I need. I know that there's a 3 to 4 to 5 relationship here. So my first piece, my first side length, the one with the 3, that's 3 of the 12 pieces. So I know every piece is 8. So if I've got 3 pieces here, I've got 8 plus 8 plus 8, that's 24 centimeters. And my 4 side, my 3 to 4 to 5, my 4 side has 4 pieces. So that's 8 plus 8 plus 8 plus 8, that's 32 centimeters. And then in my ratio, my 5 side, that's 5 of these pieces. So 3 to 4 to 5, 5 times 8, that's 40 centimeters. So the correct answer here would be D. The key here was finding the number of pieces and dividing my total value of the triangle sides into those 12 pieces. And then I use the 3 to 4 to 5 ratio. So this whole tape diagram will help you solve 5 and 6. With this problem 3, it's a little bit different. So you're given the job of dividing equally packages of cookies, cans of soup, and granola bars into boxes. All the boxes are to have the same combination of cookies, soup, and granola bars. So that doesn't mean that that I have to have like 3 packages of cookies, 3 cans of soup, 1 granola bar. It just means that however many boxes I make, however many boxes I break all this stuff into, every box has to have the same amount of cookies and the same amount of soup and the same amount of granola. So this is, you may not realize it, but this is an equivalent ratio problem, because this ratio, 180 cookies to 144 soup, that looks terrible, 144, there we go, to 108, it has to be proportional to one of these ratios. And by that I mean proportional, I mean the sizes of these numbers compared to each other has to have the same relationship as one of these ratios. So the way I would do it, to find the equivalent ratios, is I would just look at factors that I can divide each of these numbers by. So like I can see that they're all even, so that means I can divide by 2, and I would have an equivalent ratio that is proportional to the original ratio. So 180 divided by 2 is 90, 144 divided by 2 is 72, 108 divided by 2, that's 54. I can see again, I can make this smaller. They're still even, so I could divide by 2 again. So now I'll have 90 divided by 2, that's 45. 72 divided by 2, that's 36. 54 divided by 2, that's 27. So I'm making equivalent ratios, just like I would have made equivalent ratios if I did like 180 compared to 144. Remember, we could just divide both by 2, just like we've been doing. Divide by 2 to get an equivalent ratio. Well, I just did that. I just did it with 3 parts. 3 parts here. So eventually, once you factor these down, once you divide out factors that all 3 numbers share, one of your answers, you're going to have the same ratio as one of your answers. So that's how I would solve that. Good luck.